about getting your calculator. All right, here we go. So our radical function is a function of the form f of x equals nth, boys, nth root of x. The square root function is a type of radical function. Graph the parent function of the square root function below and identify the key characteristics. So we're going to go ahead and graph our 0, 0. That's our endpoint. We don't call it our vertex. It's our endpoint because we don't have a continuous graph. It kind of stops right there, so we call it an endpoint. And then if I take, let's see, square root of 1, what would that be? 1. So if you look on your calculator and you put in the value check, right? Second function trace and do one option, put in 1, you should get 1 back in your y. Do you see it? Did you get it?
Yeah.
Okay, so there's my 1. And then if I do square root of 2, will I get a whole number or an irrational number? Irrational. So what's the next whole number that will give me a whole number? 4. So 3, 4, up 2, right? If you want to check, second function trace, value, 2, enter. Oh no, 4, enter, and what do you get? 2 for y, right? Okay, what's the next one? 9. Square root of 9 is? 3. And your trace function should actually tell you that. Okay, what's up? Which part is not valid? Instead of tracing it out, second function trace will give you the calculation option. And within the calculation option, I want you to choose 1 for values. And when you put in the value of 9, what do you get for y? You got it? Okay, cool. All right, so we're going to connect the dots as smoothly as possible. And is this going to ever end? No, as long as we have all these positive x values, I will always have a y value come out, right? Okay, so with that, we can write our domain. Where does it begin? Where does our domain? Good, so it's an endpoint which is included. So we use a bracket, 0, comma, infinity, forever and ever. Okay, range. The bottom of our graph and then going upward or downward? Upward. Does it have a starting point?
Yes.
Okay, what's the starting point for range? 0. So same thing, bracket, and then what's our end? Infinity. And is this open or closed interval? Open. Okay. Endpoint is at 0, 0. This is not an interval notation. This is a coordinate point notation. Yes?
Yeah.
Okay. End behavior. Okay, this is tricky. Try to follow with me, okay? As x is approaching positive infinity, what is y doing? It's going up and up and up. So it's going towards positive or negative?
Positive.
So positive infinity and positive infinity. Okay? Now, if I go the opposite direction, what am I approaching? Am I approaching infinity in negative direction or a certain value? A certain value. What is that value? So as x is approaching 0, what's f of x approaching? 0. So positive direction is to the right of the origin, yes? And as I'm approaching x values that are greater, what's happening with my y values? It's going up and up and up and up, right? But if I'm going in the opposite direction, I'm going towards what value? It's not negative infinity because it's going to approach a certain value because it has to stop there, right? So if I'm going towards the opposite direction, I have to stop at 0. So I'm approaching 0 for the other direction. And what's the y value approaching? 0. Okay? Any questions? Yeah. For square roots, yes. typically it is going to be where the endpoint is. This might be different according to where this is. It could be underneath. It could be reflected if it's an inverse. Okay? So you want to try to keep that in mind. Okay? Increasing interval. Okay? I need you to look at it from left to right. Always from left to right. Which parts are increasing?
The right.
Yes.
For this, the notation is like we only include the x values, right, of the points.
Yes.
So I just have on here 0, positive infinity.
Is it closed interval or open interval on 0?
Closed interval.
Closed interval on 0 and open interval on positive. Then is there, if I go from left to right, is there any part that's going to be decreasing at all?
No.
Nope, so we just say not applicable. NA. Or none. Either one will do. Okay? How are we doing? Now we're going to transform. This is our parrot. That means we can change it any way we need to using our transformation form. Okay? Do you guys remember this from our quadratics? Okay. Whatever that we group the x with, we move in right or left or up and down.
Up and down.
If it's x, if it's grouped with x, we go right or left. And is it in the same sign or opposite?
Opposite.
Opposite. Okay? So this is grouped together as a radicand. Do you see that? Okay, so x and h are grouped together as a radicand. So you can imagine like invisible parentheses around them. Okay? So h is the horizontal shift. So if I have a plus h, what does that mean? Which way am I going?
To the right.
Opposite people. If I have a plus h, then it's shifting to the left. Okay. If I have a minus h, it's shifting to the right. What does the k do?
Opposite, up and down.
It goes up or down. Is it opposite of the direction you're seeing, or is it going to be the same?
It's the same.
It's going to be the same. So k is the vertical shift. And if it's positive, we are going up. And if it's negative, we are shifting down. Okay? This is all familiar, right?
Yeah.
That's why I figured you guys didn't need like 6 days for graphing, okay? Now, endpoint. Where would the endpoint be out of this transformation form? Just like where the vertex would be. Where's the endpoint? You got it. H is going to be your x value, and k is going to be your y value of your endpoint. Okay? If a is negative, the function is what? I need you to go back to the same graph that you have. Because they're in different colors, this is going to be amazing. Go to the second y2 equal, and I want you to put in a negative square root of x, and tell me what happens. What do you mean down? Joshua said we're going down. It's mirrored.
Reflected.
In math, we use the term reflected for mirrored, right? If a is negative, the function is reflected across what? X-axis. Okay. I need a number that's greater than 1. 2. If I do absolute value of negative 2, would that be still 2? Okay, so let's try another one. Do you know how to turn off negative square root of x?
Yeah.
There's an equal sign that's kind of shaded in. If you go back into y equals, okay? Are you back in y equals? Okay. That equal sign, that's shaded, go one cursor right onto the equal sign and press it, and then it's gonna turn it off.
Press enter.
You have to press enter to turn it off. Once you go move the cursor to the equal sign, press enter, and it'll turn it off. Go down to Y3. Okay. Oh, where's your square root? Square root of x. This should be negative square root of x. Okay? And then I'm asking you to turn that off. And then here, we're going to do 2 square root of x. Okay? That's your original parent. What happened? What is it doing?
It's going the same way.
Yeah, it's going the same way.
It's going the same way, but what's different?
It's not
Black. Sorry.
So the color is black, but what? What's the black line doing?
But this is like
I don't know, Andrew. Is it black line? Yeah, it's a black line. What is it doing that's different than the parent?
it's following a different trajectory.
It's a different trajectory. Alethea, don't forget 3. You could use the outlines of that if you want. Okay? So it's a vertical, it's going, I don't have it here. I'm going to do it with green. Okay, so it's going double of what we had for each of the 1, 2, and 3 value. Does that make sense? So if I put in square root of 1, and then I would multiply that by 2, what would that result in? 2. So instead of at 1, 1, it'd be at 1, 2. Right? And then if I'm at 4, square root of 4 is 2. 2 times 2 is? So it would be that much higher. And then square root of 9? 3. 3 times 2? 6. So it would be, instead of at 3, I'm at 6. Which direction did it stretch in? Up. So this is called a vertical stretch. Okay? So I'll go ahead and put this here. Y equals 2 rad x. 2 square root of x. Okay. Now let's try this one. One number could be between 0 and 1. 0.5. Okay. So let's try that one. You could change the 2 to a 0.5 and tell me what happens. You should have turned that one should be in line 2. So let's move down to this one and change it to 1. Insert, second function, insert over 2. Okay, now graph. What's going on?
How'd you do that?
So if you want to clear it, you can do that. Or you could do insert. Second function, delete, has the insert function above it. So you can do 1, second function, delete, which is insert, over 2 or 0.5. Okay? Now hit graph. What's going on? What happened to the black line this time? Ooh! Did it reduce? Did it compress down? Do you guys, oh my gosh, I'm dating myself again. Do you know what this means? If I go to 1, it's at half. Yes? If I go to 4, half of 2 is 1. What's half of 3? 1.5. Endpoint is the same, but this is y equals half of square root of x, right? What happened? Decrease. So if this is a stretch, this motion is a compression. Okay? Like a trash compactor. That's all I could think of. Compress. Compression. Okay? So 0 is less than, absolute value of A is less than 1, represents a vertical compression. So even if you flip it with the negative, it's not going to change the stretch or the compression. It's just going to reflect it over the x-axis and graph it with such compression. Does that make sense? Yes?
Yeah.
Okay. All right, let's move on. Here we go. I need you to describe the transformation. I am going to make this as simple as possible for you on the test. So I want you to tell me where the endpoint is. I want you to tell me what kind of shift it went through, the translation. And I want you to tell me if there's anything else I should know about it, such as reflection, vertical compression or stretch, by how many, what the scale is, by what value, okay? So those are my anything else part. So I'll go ahead and go through this with you. Where's the end point? HK, where's the H?
There's 7-2.
7, 2. Okay, which means there's translation happening from 0, 0. Okay, which way are we moving? Right or left?
Right.
Right, how many units? 7 units. And are we going up or down? Up, how many units? 2 units. Okay, and then anything else is going to be everything and anything about A. Okay, is there a reflection at all? No reflection. Anything else? No reflection. And no stretch or compression. Agreed? And that's all I'm looking for. No complete sentences, just simple listing of what's happening with the graph. That's it. Okay? Any questions? Yeah,
On the test, if we do like arrows instead of like.
I don't care.
Okay.
Just make sure you're pointing the right way. Okay? Okay, here we go. Let's try this one. Number 2. Where's the end point for this one?
1, 0.
Try again. 0, negative 1. Good job, Preston. 0, negative 1. Okay? That was Preston, right? No? Oh, that was you? I'm sorry, Jaden. I could have sworn it was him because it was so muffled. Oh, I'm sorry. My bad. Translation. So that was Jaden Serta. Just making sure that was recorded. All right, translation. Which way are we going? From the parent graph, if I were to take all of these off and then just move according to what it says here, are we going up or down? Down. Are we going right or left? None. So I'm just going to go down 1 unit. Just like how Gio asked me if we could do that. That's what you're asking, right?
Yeah.
Okay. As long as you point to the right direction, I'm okay with it. Okay? And anything else? Come on.
Wait, yeah, it is.
There's a stretch. Vertical stretch or vertical compression? Vertical stretch. By how much? By 4. Okay? How are we doing?
Amazing.
Is that simple enough for you?
Yeah.
All right.
Yeah. So A.
Any questions?
You have to specifically say no reflection.
No, you could just say none. If you don't want to say all that, you can certainly say, instead of any of these, that can equal to none. Nothing else that you need to say. Okay? Or you could say same as parent.
Can I put it shorter?
Same. I wrote it, so don't worry about it. I wrote it on the test for you. For the translation part, yeah, I heard you. You just need to write it out, okay? Same as parent. PF. You could say that too, okay? You could say none. You could say same as parent graph or parent function. No reflection, no stretch or compression. Any of these 3 options are possible for you to use as anything else that you want to state. Don't leave it blank. All I'm asking you is that you do not leave it blank so I don't assume that you are completely ignoring it or missed it, okay? That would be an incomplete if you leave it blank. All right, number 3. F of x equals negative square root of x plus 3. Where's the end point? Which one is it? End point is at negative 3, 0. That's correct. Translation.
Left 3 units.
Any up or down?
No.
Now, if you make that arrow as tiny as possible, I'm not going to try to figure it out. I'm just going to mark it wrong, which direction. Okay? So make it big enough that I can see. Okay? My tiny writing people, please. Ellie's not here, but she writes so small. Yeah, what?
Did you say it goes opposite?
Yeah, so isn't it left? Okay, are we good? It is negative 3.
Going left, you're going negative.
H is negative 3, yes? Since the formula is square root of x minus h, what's opposite of negative? That's why it says x plus 3. Okay?
Yeah.
Are we got it?
Yeah.
Are you sure? That gum, it's not keeping you awake? Go spit it out. Okay, anything else?
It's reflected on the x-axis.
Reflected over x-axis. Okay, and there's no stretch at all, right? So we don't have to mention anything about that, but you already put in my anything else, so we can move on. Okay, questions? Yeah.
So for anything else, we have to write everything.
Anything else would be like the vertical stretch or compression or a reflection.
So
One of those three,
multiple like that-
or all three.
So, okay, so like minimum's 1 and less
Minimum?
like
talk about
like
minimum.
do we have no the minimum of like how many you have to do.
The minimum is you write none or same as parent function.
Oh, okay.
That makes sense, right? Okay.
So there has to be one thing at least.
There has to be something written for anything else. So I know that you actually thought it through and you know that there's no changes to the amplitude of the curve, or there is a reflection, or there's stretch vertically, or stretch like a compression vertically. Okay? Yeah.
So in front of the radical, when a is a negative and it has a number on it, will that change, like, for anything else?
So if you have, let's say instead of this half, I have a negative 1/2. That means it's reflected over the x-axis and it has a vertical compression by half. Okay, so it's both. Okay, but in this case it's not, so let's go ahead and write this in. Okay, what's the end point? Let's have someone who is falling asleep on me answer. Parin.
Endpoint would be 2 negative seconds.
You got it. See, even if it's sleepiness, my students are paying attention. I love it. Translation. Translation. Leo, you want to give it a try? Translation, meaning which way is it moving, right or left, up or down? Down, how many? 2 right and?
6. Down negative 6.
Down 6. So 2 units to the right. Oops. Bloop, bloop, bloop. Units. And then down 6 units. Yeah? Okay, and then what about anything else?
Compressed.
It's vertically compressed. Vertical compression by what? By half. And reflected. Reflected what? Oh, no reflection. My bad. I was just tripping. Sorry.
In theory,
Yeah.
if it was x plus 2 minus 6, it would the endpoint would be negative 2, comma negative 6. right?
Why would it be -6 if it's plus 6?
The way we get the endpoint is we invert the -2, +2, right? Or is the endpoint the x always positive?
Okay. If I say this the wrong way, you might get confused. So I'm going to try to go back to something you guys should remember. Do you remember what we did with y equals a times quantity of x minus h squared
Yeah.
plus k? What do we do with that h every time?
Inverse.
It's the opposite.
Yeah.
I'm not undoing it. Inverse would mean that I am undoing it. Yeah, an inverse function is something different too. So I would rather have you say opposite rather than inverse. Okay? So you and I are thinking the same thing by using different words. So it should be opposite of whatever h is. Okay?
God, I just clarified.
All right. All right. Are we good? Okay. The square root parent function is reflected across the x-axis, then shift is 7 units left and 1 unit down. Write an equation that represents this function. Try to do it with your team. Try to do it on your own. Try it out, and I will check with you in 1 minute. That should take 1 minute.
How about you?
Hey, so what? Righty. Here we go. Y is equal to? Carlos, you have it? Yeah? Tell me. Okay, f of x equals, slow down. Tell me again. Square root of x plus 7 minus 1. Then what do we do with the reflected across the x-axis part, Carlos? Where? In front of the radical to represent the reflection, okay? Make sure you have that part. Any questions? Yeah.
So I'm a little confused with the stretch and the compression. How can you know which to use for?
If it's a whole number greater than 1, it's a stretch, vertical stretch. If it's a fraction, it's a vertical compression. Okay? That's why up here we have that a is greater than 1 and a is between 0 and 1. Okay? So this one would be the fraction. Okay? And this one's a whole number greater than 1.
Wait, then for the first question, shouldn't that be a stretch? Then?
This one?
Or
Is what's the a value here?
oh, nothing.
It's not nothing.
Oh,
If you don't see any numbers here, what is it?
it's just no. This one. Oh, I see.
Right? If it's positive 1, then it's identical to the parent function. So nothing's going to happen in terms of the original parent dude. Nothing's going to change in terms of the compression or the stretch. Okay? But this one does have a coefficient to the radical, which is not 1, and it's a 4. So it's a vertical stretch. Okay? All right. Anyone else? Yeah.
If I wrote f of x on the test, would it be wrong?
I would love that. I would absolutely adore you for writing f of x. If you write nothing, like no y, no f of x, no equal sign, I'm going to be like, nope. And then I'm going to say what? You need to have an output for your input function, right? So you have to have a y or an f of x, or a p of x, or j of x if you want to use your j. Okay? Yeah.
Is that type of question gonna be on the test?
Yes, it will be on the test.
Thank you.
Of course, it's going to be on the test.
Thank you.
You're welcome. All right, here we go. All right, f of x equals square root of x plus 5. Where's my endpoint? Whoa, time out. Plus 5 is not part of the radicand. Plus 5 is not the radicand. This is plus k. Where is the 5? Outside the radical. So this is going to be shifting to the left 5 or up 5? Up 5. So this is going to be 0, 5. Here we go. 0, 5. There's my endpoint. Okay? Is this going to be a normal stretch? Or is it going to be vertical stretch, vertical compression? It's going to be exactly the same. So you need to kind of imagine this as your x-axis. And then think, if I go to the right 1, that's square root of 1. What's square root of 1? 1, so it's just going to be 1 unit up. Does that make sense, what I'm doing? Okay, so you're going to treat where the endpoint is like an x-axis, and then try to plot the rest of the points using that. Okay, so if I go to the right, 4, right? I'm going to go up 2 units. If I go to the right 9 units, how much am I going to go up? 3 units. So now there's no stretch at all. Does that make sense? If you plug in these values, so let's put in 1 here. What's square root of 1? 1 plus 5 is?
6.
Isn't that 6? Okay. So what's square root of 4?
2.
2 plus 5 is?
7.
Isn't that 4, 7? Right? Okay. And then this one is? 9. Square root of 9 is?
3.
3 plus 5 is?
8.
8. So it should work no matter which way you see this. You could plug and chug and figure out what the y values are, or you can just lay it as if this is the x-axis right here, and then stretch upward the same way that you would from a parent graph. Does that make sense? Yes? Okay. Domain. Where does it begin? 0.
5.
And it goes to the positive. Is it including 0? Okay. Domain has to do with which values, Leo? X or Y? No. That's why it's 0, not 5. I just answered that for you. Okay, let's try this again. We're looking at X values for domain, Leo. Okay? Which X value does it begin at?
0.
0. So that's why we start at 0, inclusive, and then it goes to the positive infinity. Yeah? Okay, then tell me what the range is.
5.
Yes, 5 and up or 5 and down? Up. So it's going to be inclusive 5 to positive infinity.
That's so hard.
Yeah, it's totally my fault. Okay, all right, moving on. Here we go. End behavior. If I approach x in the positive infinity direction, okay, if I approach towards the right from origin to the right, what's happening?
0 to infinity.
Y values are
Infinity.
going upward forever and ever. Yes? So positive infinity, positive infinity. Now, if I go the other way to the opposite direction instead of right, I'm going left. What's happening?
5.
X is approaching 0. Okay, I'm going to say it again. Put a little man on the top of the line. He's walking backwards home. Okay? Which direction are we going in X values? No, X values. We're going towards 0 in X value, yes? Then if I'm going towards the X value here, what Y value am I approaching?
6.
Does that make sense now? What?
That was good.
You guys are so
was a good
confused about which way we're going, so I'm saying the little dude is walking back home.
He's sliding down.
Yes, so which way is that? To the left and down, right? So left is going towards what number? 0. And then down is going towards which number? 5. There you go. Okay? All right, increasing intervals. Which parts are increasing? Left to right. Always left to right. These intervals are read from left to right. Which part is increasing from left to right? 0 and then to positive infinity. Oops. Inclusive 0 to positive infinity. And then, is there any other parts that are increasing? Is there any parts that are going to dip and go decrease? No. No. So this one, decreasing is going to be? Or none.
Wait, I'm writing down the wrong one. Am I tripping or something?
I don't know. You're sitting, so I hope you're not tripping.
Oh no. What a good one with you.
I know, I'm full of it. All right, you ready? You want to try this one or you want to move on to the next part? Next one, all right. Cubic function, cube root function.
Oh, not this one. Did you do the Chewbacca sound?
Do it. I didn't watch Star Wars.
What are you?
Star Wars? No.
Wait, do it. No, he looks like Chewbacca, bro. What the heck?
Oh my gosh, you're being recorded. Be nice.
Yo, clip that.
Did I forget to hit record? Okay, never mind. It is being recorded. Okay. All right, here we go. Cube root function. You ready? Cube root. Do you guys want a quick break before we go into cube root? Okay, quick 5-minute break. All right, let's get started. Here we go. Okay, cube roots. Cube roots. The parent function for cube roots function is y equals cube root of x. I need you to try something though. On your calculator, I'd like you to put in x to the third power first.
Okay.
Okay, so that would be the cubic function. Cubic function is y equals x cubed.
Wait, I got 20.2.
I want you to put in x cubed onto your calculator. Okay?
Wait, x cubed or x squared?
X cubed. Split view. Let's pull up my Desmos. And then I'm going to put in x to the third power. So what does that look like? Sorry, you can't see it. How's that?
Oh, you meant the graph.
Yeah. I want you to graph it. Okay?
That's the exact same thing.
It's a dancing line. We know that the leading coefficient is 1. The degree of the polynomial is 3, odd. So it's going to have opposite endpoints, right? Opposite end behaviors, right? And it's going to start from negative and end up on positive. Now, this is not the opposite of x cubed. This is the inverse of x cubed. Meaning, if I switch x and y and solve for x, or solve for y, so let's see. This is supposed to be y equals, right? I want you to think this through with me and see what you find out. I'm trying to squeeze in that last lesson that I'm not going to get to. But when you're asked to write the inverse of y equals x cubed, what that's asking you to do is simply switch x and y. Okay? So if I switch it, then it will be x equals y cubed, right? Then if I solve for y, what should I do to undo this cube?
Cube root it.
Cube root it. And if I cube root both sides, on the right side, my y would be by itself. And then on the left would be cube root of x. What does that look like? The parent function for cube root function.
Wait, so
Do you get what I'm saying? Okay. So inverse of y equals x cubed. If I were to switch the x and y around and solve for y, I get y equals cube root of x. Put in this one on the second line. Put in the cube root in the second line. Y equals, I need to find my functions, cube root of x. You already have it right in front of you. I'm going to turn this one off.
That's why I said that.
There it is.
That's why I said that right.
Okay. Tell me what you notice between the cubic function and...
Oh, it goes sideways.
Yeah, it does. Before, you know how we had square root, right? But square root, we only had half of it, but no negatives. Why couldn't we have negative? Why? We can't have a square root of a you can't have an output that's a negative from a square root, right? So that's why it only gave us half of a parabola before. But now we can have the negatives because cubic root means that I can have 3 numbers that are identical that are negatives and find the root, right? So we have both sides, the negative and the positive. What would be the domain for this one? All real numbers? Okay. All real numbers are possible here. What about range? All real numbers because it's going to keep going forever and ever on the right and up and down and left, right? Okay, so let's go back to our notes. Yeah.
So then the inverse of the root of x is just y equals x to the third power?
Yeah, if you wanted to inverse the cube root function, you would swap x and y and then solve for y. And then it would take you back to y equals x cubed if you did that, okay? All right, so let's graph this one, okay? Now, the most important point is not called an endpoint in this one. It's called a point of inflection, okay? So point of inflection is at 0, 0 for the parent function, okay? And then, hold on. Leo, I will get to your question. Just give me a second, okay? Cube root of 1 is? 1. There's 1. Can I do cube root of 2? Cube root of 3? Cube root of 4? Yeah. Yes, they're all values that we can use. However, it's not going to give me a whole number y. I want a whole number y. What's the next one that I can get a whole number y from? 8. So here's 8. I'm going to go up 2. Okay. And then if I put in a negative 1 for cube root of negative 1, what's my y output? Negative 1. So I'm going to go down. And then if I put in negative 8, what would be my cube root of negative 8? Negative 2. Does that make sense? Yeah. Okay. What? We already said it. Domain is negative infinity to positive infinity. Always negative to positive, like least to greatest. We write our notations least to greatest. Okay? And then range is going to be negative infinity to positive.
Are we still not allowed to write all real numbers?
You want to write this instead?
Yeah.
Totally fine at this point. Okay? So you can do either one. Just don't make up acronyms like ARN. That's not a real acronym for that. All real numbers. Okay? Don't make things up, please. Okay? All right. End behavior. As x is approaching positive infinity, what's happening with y? Positive infinity. And as x is approaching negative infinity, what's happening with the y? Negative infinity. Hannah, let's put that book away. Okay. Which parts are increasing from left to right? Left to right. Which parts are increasing? We start at negative infinity, and we're going to go in positive infinity direction. We're only looking at the domains from left to right. Are there any parts that is decreasing from left to right? Is there going to be a dip somewhere down the road here? Where? It's going to go up and down?
I thought you meant this one. No dip.
Left to right. Always left to right when we're looking at increase and decrease intervals. Okay? And if I go from left to right, is there going to be any dips? Then there is no decreasing intervals at all. None. Okay? Or NA. I don't mind either way. Okay? Are we good? All right, here we go. Transformation. Same idea as square root. It's just cube root. H, we still approach it with opposite. So horizontal, H is the horizontal shift. And Plus means we're shifting to left. Okay? Negative means we're shifting to the right. Okay? Be careful with these two. And then K is the vertical shift. Okay, so positive means up, negative means down. Okay. Point of inflection, where is that?
0, 0.
I don't know.
How did I get 0, 0? From the parent. HK. HK. This is not an interval notation. This is simply a coordinate point notation. Okay? It's whatever H value we have and the K value we have, and that's our point of inflection. Yep.
If the H is negative, we still switch it to positive.
Okay. Any questions? We're good? Can I move on? If A is negative, what happens? Let's find out. Let's do it on our calculator. What do you think is going to happen if it's a negative? Now, this is opposite to the cube root of x. It is not the inverse. I'm asking for opposite of cube root. It's going to look tricky.
Is it going to reflect on the y-axis?
Is it y or x? Let's see.
On the y.
Y equals negative cube root. Can I do that? Nope. Cube root of x.
Oh my god.
It's actually not y.
Oh, the x-axis.
It's reflected over x-axis.
My bad.
It is. Because if you think about it, I'm flipping this down and this is flipped up. Okay? So its opposite direction would be reflecting. The function is reflected across the x-axis. Okay? Questions? Okay? It's because, okay, if it was reflected over the y, your y value should be flipped. Yes? If it's reflected over the y, then these y values that I would have 1 with should be flipped. But it's not the y value, it's the x value. Do you see what I'm saying? I hope. Okay. All right. Absolute value of A is greater than 1. What kind of stretch do you think it is? Vertical stretch or a vertical compression? Let's find out. Let's do that one. I'm going to change it to 5. Whoa, what just happened?
It's stretched a lot.
If you don't want it that high, how about that? It's stretched vertically or compressed? Vertically. So if it's above the parent function, it's a stretch. Does that help? If the new graph, the transformed graph, is over the parent function, then it's a vertical stretch. Okay? Okay, what if I put in a fraction? Instead of 1 or 2,
Compressed.
it's a compression. Same thing as what? Square root. Okay. Describe the transformations of each function compared to the parent function. So here we go. Just like the square root, you just need to list it. Stop talking. Jeez. Okay. We need point of inflection. I'm going to start naming names on this recording if you guys keep talking. Okay, point of inflection is at where? That plus 9 is not part of the radicand. 0, 9. Then what's my translation? What's happening?
It's going up 9 units.
Up 9 units. Stop talking, Camacho. Anything else we need to state?
No, that's it.
Okay.
Oh, reflection.
Is there a reflection? Mm-mm. Is there a stretch or compression? Nope. So what do we write? None, or same as parent function, or list them all. Yeah.
If I just didn't write anything else, would you mark it wrong?
Yes, I told you. I'm going to mark it as incomplete if you leave that blank blank. Okay? I need you to tell me that you read that part and you know how to answer it. I need you to know that you know there's nothing changing compared to the paragraph. Okay? All right, here we go. What about this one? What is my point of inflection? POI.
2-0.
2-0. You got it. Translation.
Going right.
Right 2? Anything else? Up, down, left, right? Nothing else, just right 2 units. Okay. And anything else? Ooh, vertical stretch by what? Anything else?
Nope.
Nope. All right.
Oh, that one's
This one is number 3 is going to be a reflection. Where's the point of inflection on this one?
-4.
-4, -7, and a reflection. This one, point of inflection, number 4?
6-1.
6-1. And then is this going to be a vertical stretch or a vertical compression? Compression by 3/4. Okay. Try number 5.
And you gotta put S, right?
There should be an output to your input, right?
Yes, ma'am.
That's good.
Yeah, you can do F of X or Y.
We'll find out. No, because you stretch this all the way over,
that's not
that
supposed
will
to be over
put that into the radicand.
Got it. It's
Okay.
not supposed to be over 3.
Correct.
It's supposed to be over 2 though.
Correct.
I can literally be anything.
Yeah. Sure.
I don't know about that one.
How do I put this 3 thing? Because is this a negative, right?
Oh, do you guys need help with the cube root putting into the calculator at all? Okay, so underneath your green button, alpha button, okay? You are not an alpha, dude. Okay, alpha button, math, press math, and then it's option 4. Okay? So underneath the alpha, it says math, right? Oops, sorry. Right here. You're gonna put math and then number 4 option. What's wrong? Okay. All right. Translation. Right. 6 units and up 1 unit. And anything else would be compression, vertical, compression by, I will tell you once we get there, 3/4. Okay. Here it is, f of x. Who's got it? Pierce. I want to hear from Pierce.
Cube root of x plus 2 is plus 3.
Then plus 3. Should this square root sign or cube root sign stretch all the way over to the 3? No, why not?
That would be a 5.
It would be a shift to the left 5 if you did that, right? Okay, so we need to separate the shifts, so make sure your radicand is only covering the h changes, okay? All right, here we go. Do you guys want to try this, or do you want to just go right into the homework?
Let's just go into the homework.
This is it. That's your homework. The whole thing. This whole page.